using two different linear expressions to define this function. It's defined to be y equals x plus 1 if x is less than 1. If I were to draw the entire graph of y equals x plus 1, of course, it would look like that. But I don't want the entire graph. I just want points that have x coordinates less than 1. And those points that have x coordinates less than 1 are on that piece of the graph. The other one, negative x plus 3. If we were to draw the entire graph there, negative x plus 3 would look something like that. Y equals negative x plus 3. But of course, we don't want the entire graph of that. We just want the piece of it that has x coordinates greater than 1. So erase, erase, erase. Yeah, that's the portion of it we want. I could extend it, actually, maybe a little bit more down here, just so it doesn't give the impression that it stops. Now we do need that much, but here we go for our function. As x gets close to 1 from the left, so we approach 1 from the left, the graph itself is approaching the point 1, 2. So the limit of f of x as x approaches 1 from the left equals what?
2.
Well, it's the y coordinate there too. As x approaches 2 from, x approaches 1 from the right, points on the graph are approaching the point
2.
1, 2. So the limit of f of x, the orange showing up, yeah, that's okay, as x approaches 1 from the right is also equal to 2. So both one-sided limits exist, and they agree. What does this mean?
That it has a limit.
That the
double-sided.
double-sided, two-sided limit, the limit, same limit that we talked about all the way up to today. The limit of f of x as x approaches 1 exists and also equals 2. So you could say, if I ask, as x gets close to 1, what does f of x get close to?
2.
And you could say 2. You don't say, well, maybe 1 if you approach from this way, and 3 if you approach from the other way. You can just say 2. It gets close to 2.